Okay, number 9. This question is asking for us to find the value of A, so it's important to realize that A is part of an inscribed angle. The vertex is on the circle, and when I look at the intercepted arc for that inscribed angle, hopefully you realize that it's a semicircle. So if that arc is 180, remember the inscribed angle is always half of the arc. But be careful, that doesn't mean that A is worth 90. It means that 15A is equal to a 90-degree angle. So when I divide by 15 on both sides, I get that A is 6. Okay, number 10. What is the measure of arc MJ? Well, arc MJ happens to correspond with this inscribed angle. Notice that this arc fits completely inside of that angle, no more, no less. So if this angle is 32 degrees, this arc is double that angle, making it 64 degrees. Okay, next, measure of angle LJK. So LJK, well, if I look to its intercepted arc, I realize that the arc that fits entirely inside of it, no more, no less, is 82 degrees. So I know that the angle is going to be half of that, making it 41 degrees. And now they're asking for this random angle LNK. Now you're going to find a method for solving this in the next lesson, but here's kind of a backup. What we might hopefully notice is that we have a triangle formed here. And what do we know about all the angles of a triangle? Well, we know that they add up to 180. So if I subtract the two angles I do already know here, the 32 and the 41, if I subtract them from 180, I'm going to get this angle in here. So I know this angle is a 107-degree angle. And I know, I'm supposed to be looking for this angle, not that one. But remember that we have what's called, get right pen, we have what's called a linear pair here. If this is 107, I can find that angle because a linear pair is always going to be supplementary. They add to 180. So if I subtract the 107 from the 180 now, I'm going to find that that angle they're looking for is finally worth 73 degrees. Okay, next page. Okay, each quadrilateral described is inscribed in a circle. So I don't care that they're not providing me with an image. I can figure out what I'm looking at. So in this one, if I have a circle, they're telling me that angle A is inscribed in that circle. So I know the vertex is on the circle somewhere. I don't exactly know how it's placed, but I know I have a 53-degree angle. Never mind, I'm being silly. I completely am thinking of a different question. Okay, quadrilateral. I have a circle, and I have a quadrilateral inside that circle, inscribed, which means that I have a four-sided shape that fits so perfectly inside of this circle that it couldn't possibly be any bigger. All the vertices, all four corners are going to be on the circle. So it does not have to be equilateral. It doesn't have to be regular where all the sides and angles are congruent or anything like that. All I know is I have this random four-sided shape inside of the circle. So A, B, C, D. They tell me angle A is 53 degrees. They tell me angle B is 82 degrees. They want us to find angle C and angle D. Now, one of the theorems within your lesson told us if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Opposite angles meaning like A and C, also B and D. Supplementary meaning they add up to 180. So to find angle C, I realize it needs to be supplementary to angle A. So if I know they add up to 180, I'll subtract 53 from that to find that angle C is 127 degrees. To find angle D, same situation. It's supplementary to angle B, so I'll subtract 82 from my 180, and I find that angle D is going to be 98 degrees. Next random circle with a quadrilateral inside. Okay, RSTU, we have RSTU. Okay, so angle S is 104 degrees, angle T is 55 degrees. They want us to find R and U. Again, opposite angles are supplementary. So to find R, I look to T, and I realize that if I do 180 minus 55, that makes angle R worth 125 degrees. To find U, I look to S. Since I know they're supplementary, if I subtract 140 from the 104 from the 180, I'm going to get an angle of 76 degrees. Okay, next. This time, we have our circle, we have our quadrilateral JKLM. They tell us that angle J has 90 degrees, so it's a right angle. They also tell us that K and M are congruent. So, let's start off with finding the measure, actually, of angle L. I'm going to kind of go through these out of order because I know L by looking at J. If these are supplementary and J is already 90 degrees, I know L is also 90 degrees. Now, if I have these two 90-degree angles, I know that they already add up to 180. And if I think back to a previous chapter when we talked about the sum of the angles inside of a polygon, hopefully you remember that the four sides or a quadrilateral always has angles that add up to 360, right? A triangle's angles add to 180, quadrilateral's angles add up to 360. So if these two already add up to 180, that means these two also have to add up to 180. And if they have to add up to 180 and are also congruent, well, actually, that means they're all worth 90 degrees. Okay. Next, determine whether these quadrilaterals can be inscribed in a circle. So we're going to work with that opposite angles being supplementary concept. So I want to start off with finding this missing angle over here. Remember that all four angles in a quadrilateral add to 360. So if I subtract the 3 that I know right now from 360, I find that the fourth missing one is 73. And now we want to know, are the opposite angles supplementary? So in other words, does 118 plus 62 equal 180? Well, yes they do. And does 107 plus 73 equal 180? Well, yes, they actually do. So that means this, in fact, could be inscribed in a circle if I were to draw one around. I'm not even going to pretend that I would know how that's oriented, but yes, I would have to pay close attention. Number 5. Again, find the missing angle first, subtract the 3 you know from 360. We find that this missing angle is 88 degrees, and then we check, are the opposite angles supplementary? Well, 124 plus 90, that's not going to be 180, that's going to get me 214. And then the 58 plus 88, that's not 180, that's 146. So this does not follow that quadrilateral inscribed in a circle rule. This is not capable of being inscribed. Number 6. We have, if you pay close attention, we have parallel sides here, one pair of parallel sides, making this a trapezoid. In addition to it being a trapezoid, the two non-parallel sides, the non-bases, the legs, they're congruent. So this is actually an isosceles trapezoid. And if you remember the properties of that, the base angles are congruent. So if this is 63, then this is 63. Basically everything about this is symmetrical down the center. and then the consecutive angles are supplementary. So if this one's 63 and I subtract that from 180, I find that this is 117 degrees. And again, my base angles are congruent. So if that's 117, then this is 117. Now that I have all 4 angles, the question is, can this be inscribed in a circle? Are both pairs of opposite angles supplementary? Is 63 and 117 supplementary? Yes. Is 117 and 63 supplementary? Yes. So this could in fact get inscribed in a circle. Okay, number 7 is showing me a quadrilateral where we have one pair of opposite angles, and I know nothing about the other pair. But what I do know about this pair is that it's two 90-degree angles. And if they're two 90-degree angles, they are most certainly going to be supplementary, right? They add up to 180, which means I don't even care what the other 2 angles are. They also have to be supplementary. They have to add to 180 because a quadrilateral will always have all 4 angles add up to 360. So without even knowing actual numbers, this definitely can be inscribed. Okay, last set of questions. Actually, I'm going to continue this set on the next video.